Turn the lights back on. Wow. Retro electro tech. When real audio ruled the world.
Greetings once again, ladies and gentlemen. This is Retro Ernest of Retro Electro Tech, and I am elbows deep into the ARP Odyssey model 2813. And in the previous video, which I will post a link to below, and also at the end of this video there will be a link as well, this unit would not power up, and upon popping the hood I found a blown, or shall I say open fuse. And also I noticed the filter caps, which are over here, that they were physically leaking, or are physically leaking. And but I'll get back to that in a moment. As I always say, and as many of us know, the power supply, which is this board here, is the heart. So I'm going to want to start by checking the health from the line side of the power transformer on through to the regulation circuitry and out from there. Okay, so before I even put power to this board, I just want to once again just comb through it, make sure that the transformer didn't sustain any damage. Like I said, there was a blown fuse in here, so who knows exactly what happened. And also too, I want to check these transistors, which you see just laying here on the board. And let me actually go ahead and zoom in. Okay, so here we are, zoomed into the board a bit, and you can see the transistors that I pulled from circuit for testing. And these are the transistors that are involved in the regulation of the negative supply. So again, if these are in spec, that'll be a good thing. I'll get them soldered back in if they are. If not, I'll replace what I need to replace. So also here's the leads of the two pass transistors lifted out of circuit for testing as well. I've already started checking tolerances of these resistors here. You can see I have some of the leads pulled from the board. These are the ones I was receiving anomalous readings on due to parallel resistances and so forth. So anyways, I started that process in the interest of time. But anyways, let's go ahead and get going. Otherwise, as far as I want to get some power to this transformer for starters, and obviously we're going to get power on the primary, see what's happening on the secondary. Let's make sure nothing's damaged with this unit. Again, as I mentioned already, there was a blown fuse in here, so who knows. So let's get to it. Okay, so over here we have our variac, and we are monitoring the output of the variac via this multimeter here, this DMM. And let me go ahead and swivel this around. Over here we're going to be monitoring our secondary. And also too, I want to mention that the transformer here, everything's removed from the board, so that transformer is isolated from the power supply board. So let me go ahead and get to it and see what we got going on. So you can go ahead and keep an eye on the secondary. And I'm at 20 volts. $30 volts, 40 volts, 50 volts, 60, 70, 80, 'Yeah, we're looking good over there on the secondary, so 90, 100. So let me just go ahead and get it up to 120. And there we are. Okay. And what do we have there? 25 volts. Okay. And of course, you know, there's no load on that transformer, you know, no regulation, no nothing, so that's what we're getting out of the secondary. Let me go ahead and check both legs of that secondary. Okay, I'm going to disconnect my positive probe, clip on over to the other side, and we have, yeah, 25 over there as well. Okay, good. I'm just glad that the transformer isn't kaput. Okay, so let's move on from there. I just wanted to mention before I move on to component testing, this area here was where the original fuse was mounted, and it was a pigtail fuse that was soldered directly to the board via this hole here and this hole here. Also, you'll notice that there's these holes here which were already here on the board. I didn't add those, and so what I'm going to do is just add a fuse clip to the board, and it happens to line up nicely with one of those holes, and it still gives me access to the through holes, the one on this side and the one on this side here, so I can solder on a couple leads to these terminals and pass them through those holes there and solder to the circuit board, you know, mount this nicely in place, and the next cat isn't going to have to deal with desoldering a fuse next time a fuse has to be replaced. So there you go. I just wanted to mention that. Oh, and by the way, I just wanted to quickly mention, some might be wondering why I don't just mount a fuse holder to the rear of the unit. And I don't want to mess with that. I don't like to alter the original cosmetics. Like I said, those holes were already on the power supply board where that fuse was originally positioned, so that's not a big deal. That can always be removed. I doubt if anyone would ever want to go back to the original pigtail fuse, but you know what, if they do, it's not a big deal just removing that fuse clip that I'm going to install. But as far as drilling into the back of the unit and installing an external fuse holder and all that stuff, I'll leave that to the next guy if that's what they decide they want to do, but I'm not going to, again, alter the cosmetics. Okay, so let's start by testing these electrolytics here, these 250 mic 50 volt caps that are physically leaking this electrolyte here. If I bring it up too close, it's going to lose focus, but you can see what I'm talking about. Both of these caps are leaking from the top there, and anyways, let me go ahead and get these hooked up here. All right. these are funny little short leads, but anyways. So at 120 hertz, yeah, 266, 0.7 ESR. Actually, you know, that's not bad, all things considered. And of course, we know this cap is degrading. There's no ifs, ands, or buts about it. This cap is from what, 1974, but anyways, it just goes to show you can still obtain readings that don't look that bad, even though these caps do need to be thrown in the garbage. But yeah, not bad. You know, a little high, but you know, within tolerance for sure. So let me go ahead and clip on the next. And there we are. 222.3 mics at 0.6 ESR. So yeah, not bad, not bad. So anyways, let's go ahead and move on. You know, even though these caps are looking good, they've got to go. So okay, so now I'm going to check the transistors that I pointed out that are involved in the regulation of the negative supply, and as such there are two 2N3906s and two 2N3904s. So all I'm going to do on camera is just check 2 of each, and then after that I'll move on to the pass transistors. And so I'm not going to check everything on camera, but I will let you all know the verdict on all of them, of course. So let's go ahead and get to it. Okay, so I have a 2N3904 NPN transistor hooked up, already brought into calibration. Okay, and let's go ahead and see what our gain is. And we're right about 120 on our gain. And you know what, let's go ahead and see how that coincides. It was 120 actually and some change, but let's see how it coincides with this little tester here. Let's see if they agree somewhat. Okay, and on this tester here you can see it's showing me 110 on the beta, or the HFE, the gain. So anyways, a little difference there, but still in the ballpark, and you can expect different results like that between these different testers. So, you know, not a big deal. Let me just turn that on again. Let's see what it gives me a second time around. Yeah, 110. So, you know, again, not a big difference between the two testers, and like I said, you can expect some differences between different types of testers. And so anyways, I'm going to move on now to the other transistor. The next one's going to be a PNP, a 2N3906, and let's see what we get there. Okay, so here's our PNP. Just let me touch up the calibration just a hair, and let's see what we got here. And we're a little bit shy of 140 on this tester here, maybe about 139, right about there, according to this. Let's go ahead and see what we get on the other tester just for kicks. Okay, my other tester there, what did I say, about 139 on the gain, and this one's 134. So again, we're close. So that was the last transistor that I mentioned that's involved in the regulation of the negative supply, those 4 transistors. There was the 2 2N3904s and the 2 2N3906s. So I'm going to move on to the pass transistors and see how those are doing. Okay, so here's our first pass transistor, which is a 2N6179. And our HFE, our gain, is looking low, and I noticed it was the same with the other tester as well. Now let me just go ahead and clip onto the second pass transistor there and see what we got. Okay. Okay, let it do its business here and see what we got. Okay. And we're showing an HFE of 23. Yeah, that's low. And like I said, the other tester was in agreement as well, close enough. So the main thing that I wanted to see on this board, I'm going to make a determination after I do some testing whether or not I'm going to replace these 2 pass transistors. But again, what I wanted to say was my main concern was I wanted to suss out any components on this board that may have been responsible for that fuse opening up. And other than, and let me go ahead and, other than this IC right here, this regulator for the positive supply here, other than that, I've tested everything on the board. I've gone through, checked resistor values. Everything is checking out good with the resistors, except for one resistor here that's out of tolerance. I think this is a 270k ohm resistor that is with a 10% tolerance, and it's a little over 300k. So that's going to get replaced. But everything else, as far as resistors go, we're within tolerance. Like I said, all of these transistors here for the negative supply were within tolerance according to the data sheets. And other than the pass transistors, which are just low in the gain department, you know, we don't have any open junctions, any shorted junctions, anything like that. So I'll be honest with you, you know, once I get, you know, the fuse clip installed, the new fuse in, get everything soldered back in, I'm going to go ahead and power this board up and see where the voltages are sitting, and you know, adjust these trim pots if need be, and get the see if I can get the voltage sitting right where it needs to sit, despite the low HFE of the pass transistors. And I'm just going to check everything out, but there's no reason to believe at this point that there's anything on the board that's that was causing that fuse to open up. And as we know too, there may be nothing within this synth that's causing that you know, that caused that fuse to open up. You know, that could have been on account of something external, including a surge as far as the line voltage is concerned. And so, you know, it could have been on the line side of things. Somebody could have plugged in something that shouldn't have been plugged in. So who knows? Who knows what was done in here? There was definitely signs that somebody has been in here. But again, I've got this power supply board isolated is the point. So once I power this up, when I get everything back in place, if everything looks good on this power supply board, then I'm going to obviously start checking all the other boards, okay? And let me just go ahead and back out real quick. And as you can see here, you know, I have all these boards pulled out, and I'll just do what I have to do and trace out one board at a time. If everything looks good with the power supply, that is, then I'll just go one board at a time and see what there is to see. And if I have to suss out a component on one of these other boards that's causing an issue, well then, you know, I'll cross that bridge at that time. But like I said, it may not even be anything within this unit that caused that fuse to open up. Anyways, that's that. So there's going to be obviously more parts, and until I get this thing ready to go. So like I always say, until next time, peace, love, rock and roll, and of course, vintage audio. So stay tuned.
This is a poor man's shoe production.